So we are solving this example today. The example is about exponential Fourier series. The question is about find the exponential Fourier series of the rectified sine wave and plot magnitude and phase spectrum. Coming to the solution of the given question, the solution will be written by first writing the function f of t. From the waveform we can see it is a sine wave, so we can write amplitude A is the amplitude of the sine wave, sine omega t, where the time period is from for the sine wave is from 0 to 1. Okay, and for this omega is the frequency of the sine wave, which is given by 2 pi upon the time period, which is given by 2 pi. The complete cycle for a sine wave is 2. So 2 pi by 2, the angular frequency is given by pi. By substituting pi, f of t can be written as a sine pi t. Okay, so next step is to find out the fundamental period. The fundamental period for the given waveform is given by fundamental period is given by the capital T, which is equals to Z. It is repeating for which after 1 second it is repeating, so the fundamental period will be 1. So coming to the next part, let the initial time period will consider as 0. So t0 plus t would be 0 plus time period. Just now we got it as 1, so it will be from 0 to 1. And the fundamental frequency will be now fundamental frequency will be given by omega 0, which is 2 pi by t, which is 2 pi by 1, can be given by 2 pi. So the fundamental frequency is 2 pi. Hence now we can write the formula for exponential Fourier series. The formula for exponential Fourier series is given by f of t is equals to summation of n equal to minus infinity to plus infinity Cn e to the power jn omega naught t. By substituting omega naught as 2 pi, we can write this is equal to summation n equal to minus infinity to plus infinity Cn e to the power j n 2 pi t. Alright, so this is the exponential Fourier series. Now we need to evaluate the Cn, which is the exponential Fourier series coefficient. Then after we can substitute in this formula and find out the exponential Fourier series. So what is the formula we discussed in the last class? The formula for Cn, which is the exponential Fourier series coefficient, which is 1 by t integration t0 to t0 plus t f of t e to the power minus jn omega 0 t dt. which will be equal to the period we just found out as 1. The period is 1, so 1 by 1. Integration t naught we assume as 0, and t naught plus t is equal to 1. And f of t we can substitute from the previously, that is a sine pi t, and e to the power minus jn. In place of omega naught you substitute 2 pi t dt. Now we can use the formula for sine pi t, which is given by in exponential form, which is given by e to the power j pi t minus e to the power minus j pi t upon 2j. This is the formula for sine pi t. Multiplication with e to the power minus jn 2 pi t dt. Now since they are in exponential form, so we can multiply this exponential form and add their powers. So the next part would be equal to, it is equals to a by 2j I am taking outside, and the remaining part integration 0 to 1. First, if you add the power, that is e to the power j pi 1 minus 2n t dt minus integration 0 to 1 e to the power minus j pi 1 plus 2n t dt. Now you know the integration of exponential functions, which is given by, first one will be e to the power j pi 1 minus 2n t upon j pi 1 minus 2n, limit is 0 and 1. The second one also will be e to the power minus j pi 1 plus 2n t upon minus j pi 1 plus 2n. This is also limit 0 and 1. So that is the result. Now, if you substitute the limits and subtract them, then together their exponential function will be added and the value will be equal to, this calculation you have to do by yourself. So it will be 2a upon pi into 1 minus 4n square. So this is the final result of Cn. Now Cn, we cannot substitute, we have to find out C0. From the Cn we can find out the C0. Sometime here n equal to 0, if you substitute, sometime we may not be able to calculate, but this is the formula for Cn. Now we can write down what is C0. C0 by substituting n equal to 0, we can write this is C0 is 2a by pi. Okay. Now the sum, by substituting these values in the exponential Fourier series formula, we can write that the exponential Fourier series of f of t will be given as C0, that is, we can write C0 separately, C0 plus n equal to minus infinity to plus infinity, where C0 already written, so it is n not equal to 0, you can write, and this is Cn e to the power j n, sorry, j2n pi t, j2n pi t. Now we can substitute C0 as we got it as 2a by pi, And the second one also we can substitute summation n equal to minus infinity to plus infinity and not equal to 0. In place of Cn, you can write 2a upon pi 1 minus n square, and this is exponential j 2n pi t. Okay, so this answer is for the first part, where you have to write this is the exponential Fourier series expansion. Okay, now the second part in the question is about to plot the magnitude and phase. Plot the magnitude and phase. For that, you only need Cn. Cn, as we got Cn is equal to, we got it as 2a by pi 1 minus 4n square. Now you substitute different values of n. For example, C0 you already got. C0 you substituted and you got it as 2a by pi. Okay. Now C1. C1 is equal to, now if you substitute 1 in place of n, this is going to be 2a pi into 1 minus 4. So it will become minus 3 pi. Okay. Whereas if you put C minus 1, this is going to be 2a by, this is also, if you take minus 1 also, the in place of n, that is going to be same, that is 2a by minus 3 pi, because n square means if you take minus 1 or plus 1, that is going to be same. Okay, so C1 and C1 is equal to C minus 1, which is 2a by minus 3 pi. Similarly, C2 also will be equal to C minus 2, which is equals to 2a by, so it will be 2 square will be 4, 4 into 4 will be 16, 1 minus 16 will be 15 pi, so minus 15 pi. Okay, similarly C3 and C minus 3 also can be written as 2a upon pi 1 minus 3 square will be 3 square 9, 9 into 4 will be 36, so minus 35 pi. Okay, so we have all these values. Similar, we find only 3 values of n. Then after in the plot we can write dot lines and substitute. So this will be the plot. This is having the calculation. From here you can find out the magnitude and the plot, magnitude and the phase. Since magnitude we can take, this is negative signs, we can make it as positive when you take the magnitude. But for the phase, it will be 0 degree as they are constants. So the plot will be like this. C0 will be, magnitude is same as 2a by pi. C1 and C minus 1 magnitude will be 2a by, how much it is? 2a by 3 pi. C2 is equal to C minus 2, which is equals to 2a by 15 pi, and C3 is equal to C minus 3, which is equal to 2a by 35 pi. Okay, and the angle of all the C0 and C1, whatever it may be, C minus 1, all the angles of this would be equal to whatever is equal to 0 degree. So from this we can plot the magnitude and phase plot. That is, first one, you draw the magnitude by writing n in the x-axis and mod of Cn in the y-axis. So first 0, at 0 the value of the Cn mod is 2a by pi. You can write 2a by pi on the top. Then you take 1 and minus 1. At both 1 and minus 1 the value is 2a by 3 pi. That's why it will be shorter. So this will be 2a by 3 pi. And this is also 2a by 3 pi. And at 2 and minus 2, this is more shorter. That is 2a by how much? 15 pi. This is 2a by 15 pi. So this you can draw also for 3, which is 3 and minus 3, which is 2a by 35 pi. This is also 2a by 35 pi. And this is the magnitude plot. For the phase plot, you have to draw angle of Cn versus n for 0, 1, 2, 3 and so on. Minus 1, minus 2, minus 3. So all these things angle is 0 degree. So you just need to put a circle on the x-axis. Okay. And even you can draw a dot line for in the right side, saying that for all the positive value and all the negative value, you can put dot lines. So this may continue. Okay. Even for this also you can put dot lines of n, and for this also you can put dot line. Okay. So that second one is you can label it as phase plot. So that is the solution. You have to make it by doing the exponential Fourier series and their magnitude and phase plot. Thank you.